All right, y'all. As promised, we are back with part two of the HPA regulator, um, talking about how the regulator works. And I mentioned that I was going to show you a reverse engineered CAD model and explain exactly how this thing actually functions. So let's open my CAD model. So this is what the HPA regulator looks like. The only thing it's missing is the pressure regulator that's in here, but you can see the only reason I leave it out here is because I actually modify this port to add additional lines in here so I don't have it in the overall assembly, but you can just assume that it is in there. We're not really going to talk about it a whole lot. We're really going to focus on everything else that is inside this regulator. So yeah, let's get into it. So I'm going to show you a cross-sectional view of what this looks like. And so remember, this is the side that connects to our tank. And then you can see that there's a line that travels all the way through the body, and it splits into different chambers here. And this first chamber here is the fill port that I was showing before in the physical video. And then the other side goes to the high side burst disc. Okay. And then the center line goes into what we call the output manifold. So this may look like separate volumes, but in reality, if this is open as it is right here, you can see that this is our piston. So this blue part right here makes up our piston. And so currently the piston is shown in an open configuration, which means it's not sealing on this face here. So that means that this volume is free to take the pressure coming from the tank and begin filling up this chamber. Now you'll notice that there's this black hole right here, and that is what connects this black chamber into this little golden canal here. And this canal connects to this larger chamber. Okay, so this is the same chamber that has the spring that is constantly forcing this pin valve to be closed. But it also doubles as the chamber that is going to be responsible for pushing this piston back the other way. So to break this down, I think the easiest way to look at this is to break this down into 3 different stages that the regulator goes through. Okay, so what I've done here is I have in Snagit created some slides to just show everything about how this thing functions. So in the previous video, we talked about the different components. So we have our valve body, which is this whole orange section here. And then we have our fill port, which is this purple section, along with this little pin valve for itself to prevent the gas from leaking while I'm not filling. And the other side goes to a bottle burst disc to prevent a overpressurization event of the bottle pressure. Then we have our piston assembly, as we described before, the blue. And now this is kind of the new part, the Belleville spring pack, where those concave, convex discs that we saw on the inside of the valve. And then we have our bonnet section, which is really just like the cap of this valve. It just holds everything together. And then we have our pin valve right at the top. Okay, we did want to talk about the inlet port. So on the inlet port, you'll notice that there is that little pin valve. And so the way the pin valve works is, you can see in the previous slide, the pin valve is sealing. It's actually not sealing. So when you are not pressurized on the bottle pressure side, there is no force that's being acted on this. Okay. But when there is bottle pressure, it's going to put a force on one side of this pin valve, and it's going to force the pin valve to take the O-rings and squash it against the rest of this adapter, and that will create a seal such that this bottle pressure cannot escape to this ambient pressure side, or really any pressure that's lower than the bottle pressure. But when there is no bottle pressure, you're going to see that this pin valve actually can drift anywhere in between here. Okay. Uh, but if I am filling, what will happen is there will be a higher pressure on this side, and it's going to cause this pin valve to slam the other direction. And notice that there is a little opening here, and that opening is actually connected to the rest of this volume here, and so that provides a path for the air to go around and then start to go into the bottle. So that's the process of filling. Okay, we talked about the burst disc and how it's a thin disc that will rupture at a certain pressure, just for safety reasons. So that's really the bottom section of this HPA regulator. Now, let's talk about the different stages. So the first stage is when the bottle pressure is starting to increase, and we have this pressure being distributed throughout all of these different sections. We've already talked about these two. Now up here, what's going on? So when the pressure starts to rise, what's going to happen is let's just say that this piston is being compressed up against here, and it's sealing right now. And so when the pressure starts to increase, it's going to provide a force on this piston, and it's going to force this piston to start to open up. Now, the next stage is the pressure building stage, which is when now the piston has traveled up, and so this new volume has access to the bottle pressure. So the bottle pressure starts to increase the pressure in this new volume, okay? And this new volume we call the output chamber. You can see it's all connected to each other. And this little hole right here is what is allowing the connection from this black region into that whole canal section with this larger volume, which we call the output chamber. Okay, so like I said, intake stage, really all that's happening is we are forcing the piston upward. In stage 2, because that piston is opened, now the bottle pressure is going into here, and the actual pressure of the output chamber is starting to increase. Okay, the third stage is what'll start to happen is because this volume is starting to increase in pressure, we will have a downward force being exerted on the piston. This downward force is going to start to compress these spring packs. Okay, so all of these little discs made of metal are going to start to get crushed. Okay, but it's not going to be enough to crush it that it permanently damages it, but it's going to be in its elastic region, and it's going to provide a balancing force. Now, what we'll start to see though, from a pressure standpoint, in the pressure building phase, we are continuously increasing our pressure, and then something starts to happen. Okay, so as these spring packs start to get compressed, the actual piston will be allowed to start moving downward because we have this downward force. Okay, so the spring packs are literally going to start getting squashed because this force is going to start squashing them. Because they're getting squashed, the whole piston will start to move down until it seals against the inlet surface. Okay, so you can see that here. So if we have two different displacements, one being the open state when we first saw back here in the intake section where we first open up this piston, we can see that we start in the open state, but as this pressure starts to increase, the force that's acting on this piston is squashing this spring pack even more, and we reach the displacement of being closed. And so this is why we call it the sealing stage, because now we are in the sealing state. Okay? And usually, I mean, not really usually, but in all of these HPA regulators, there is a fixed set pressure, which means that they have precisely added enough of these little spring packs such that whenever you reach a very specific pressure, it will start to seal. Okay, so when you are at that, you are, let's just say that the pin valve has not been opened yet. Okay, so at this point, that set pressure is constant in this chamber. Okay, now after you finish the sealing stage, if the pin valve never gets open, it will just remain closed constantly. Okay, so it just has to really do this cycle once, initially when the bottle pressure increases, so that you reach the set pressure at the outlet. Now let's say that I go and I open up this pin valve. Now this output volume has a place to escape. And as a result of that happening, we will start to see that the pressure set point starts to drop. Okay? I mean, not the pressure set point starts to drop, but the output pressure starts to drop. And as a result of that, the spring pack is no longer being compressed nearly as much because the force that was acting on it originally is much lower. And so now we'll start to see that the piston goes back up a little bit. And then the pressure starts to be compensated as a result of that. And so there's this nice little tandem game happening between the pressure on the output side and this compression of the spring pack that will allow the pressure to get regulated up into a certain point. So what we'll really see here is, you'll see the pressure start to drop when that pin valve first opens, but then as this displacement starts to move to being closed, this being dropping down will allow more pressure to come into that same manifold, and as a result, we will notice a corresponding change where it comes back up. And so there's this whole little ripple effect between the two, displacement and pressure, to where they kind of align with each other back and forth, back and forth, back and forth. And they essentially regulate very close to the set pressure as we start to consume this pressure. Okay, that's pretty much all it is. That cycle will keep repeating again and again and again until the bottle pressure is no longer high enough to even open up this this piston anymore. But yeah, I hope that was helpful. There's not much else that is really left to talk about in here. But yeah, if you enjoyed the video, if you found it very helpful, I'm going to attach a link to my website where you can find all the information, CAD model, everything, more information about all of the different components in here. So yeah, if you're interested in that, check the description. But other than that, if you liked the video, please subscribe. I would heavily appreciate your support. So thank you.